Okay, so this is a problem from section 1.5, and they're asking us to solve this using a substitution. Okay, so what they're actually talking about here is using a u substitution. And when we're using u substitutions, the whole goal of it is to try and get something that looks like it's in a quadratic form to actually be in a quadratic form so that we can use the tools that we use on quadratics to solve. So something like this, what I would do is I would say, let's let u equal, excuse me, let's let u equal whatever this is right here. And since that's an x to the 1/3, I'm going to let u equal x to the 1/3. And then if I were to take this and square it, and squaring it would mean squaring this side, but also squaring this side. So when you square something that already has an exponent, you actually multiply. So the u squared here would actually be x to the 2/3. So what you can see is that this x to the 2/3 is going to become my u squared. This x to the 1/3 is going to become my u. So this problem actually becomes this. It becomes u squared minus 4u and then minus 12 equal to 0. And the reason we use this u substitution is this is much easier to solve than this. Okay, so once we solve this, what we'll do is we'll back substitute x and solve for x. Okay, so this factors, it's going to factor into u and u, and 6 and 2, a minus sign there, and a plus sign there. Okay, and then when I solve further, set each piece to 0, then I find here that u is equal to -2, add the 6 here, and find that u is equal to 6. Okay, so that's what u is equal to, but we were trying to solve for x. So what we have to do is go back up here, and where it says u is equal to 1/3, I would back substitute. So this is actually, since u and x to the 1/3 are equal to each other, this is actually x to the 1/3 equaling -2. Okay, and then over here I have x to the 1/3 equaling 6. And now I'm solving those two pieces. Okay, and the way to solve these, fractional exponents, if you remember, x to the 1/3 is the same thing as the cube root of x. Now, I don't really need to convert it. What I can do, though, is just remember that if I cube both sides here, when I take power to a power, again, I'll multiply. 1/3 times 3 is actually just going to give me an x to the first power, which is the reason for doing that. And if I cube this side, I have to cube this side also. Okay, so -2 to the 3rd power is going to become -8. And then over here, when I cube both sides, this is going to become x, and this is 6 cubed is 216. Okay, so these would be our two solutions there. And it's often helpful to check your solutions in these problems. You could go ahead and take -8, plug it in here, into each of these and make sure that it makes sense. And same thing with the, same thing with the 216. Okay, and then a related problem, very, very similar, was asked also. It was this problem right here, 1.5.69. It's basically the exact same scenario here. We're asked to use a u substitution, and we have 2x to the 1/2 plus, that's a 1/4 right there. So this is plus x to the 1/4 and then -1. So I'm going to do the same thing here. I'm going to let u equal x to the 1/4 power, and then u squared would actually be x to the 1/4 squared, which would become x to the 1/2. Okay, so everywhere there's a 1/2, I can plug in u squared, and everywhere there's a x to the 1/4, I can plug in u. And this thing becomes u squared, 2u squared, because we have a coefficient of 2. And then we have plus our u, and then -1 equal to 0. Okay. And again, you know, this is going to factor. So if we use 2u and u, and a 1 here and a 1 there, if I make this positive and this negative, then that'll factor. Okay? And then I'm going to set each piece to 0. So set this piece to 0 and this factor to 0, and then solving separately. So if I add 1, 2u equals 1, and then divide by 2, so u is a half. Here I would subtract 1, so u is equal to -1. Now I'm going to back substitute again. So up here, again, we found that u is x to the 1/4. So what I'm going to do here is say x to the 1/4 is equal to 1/2, and I'm going to solve that. And then I have x to the 1/4 is equal to -1. Okay, so just get a different piece of paper here. So what we're looking at, x to the 1/4 equaling 1/2, and x to the 1/4 equaling -1. Okay, so what we need to do now is take both of these sides to the 4th power. And the reason for this is what we want to do here is, you know, get rid of this denominator of a 4. When I take 1/4 to the 4th, power to a power, I multiply. So this becomes x equaling 1 to the 4th is 1, and 2 to the 4th is 16. So x equals 1/16 would be one of my solutions. Okay. Now, on this one, we actually have to notice that this is x to the 1/4 equaling a negative. Remember what this is. This is actually the 4th root of x equaling a -1. Because this is an even number, there's no way that I'm going to be able to take the 4th root of something, some value here, and get out a negative. 1 second, I'm doing a video. I'm almost done. So what we can do here is you can still do the mechanics of x to the 1/4 equaling -1, and you could take this to the 4th power and this to the 4th power, and you're going to get x is equal to 1 here. But this isn't going to be a solution. So what you can do is you can take it back into your original problem and check to see if it's going to be a solution, like I was saying on the previous problems. You know, see. So if we check this one, this is going to be 2 times 1 to the 1/2 power plus 1 to the 1/4 power minus 1 equaling 0. Okay, so this right here, 1 to the 1/2 power is just 1, so this becomes 2. 1 to the 1/4 power is 1, and we have minus 1 equaling 0. So we get a contradiction here. We get 2 is equal to 0. 2 is not equal to 0 here. Okay, so you could have figured this out in a couple of ways. You could have, like I said up here, just recognize that the 4th root of x equaling -1 is nonsensical because you can't take an even root of something and get out a negative. Or you can just do your mechanics, solve it, get x equals 1, and then go back in and check it and see that it's not going to work there. Okay, all right, that's it.